Hi students, today we are going to see the limit cycle in finite word length fx with integer as initial condition, and this is Benila. So let us see how to solve the limit cycle problems if the initial condition given is an integer, right? So explain the characteristics of a limit cycle oscillation with respect to the system described by the equation. So they have given the system equation as y of n equal to 0.95 y of n minus 1 plus x of n. The system is excited by the input x of n equal to 0, and the initial condition here they have given is 13. That is the integer value, right? Determine the deadband range of the system, right? So here they have given the system that is going to be y of n equal to 0.95 y of n minus 1 plus x of n, and they ask you to find the deadband, right, along with the characteristics of limit cycle oscillation. So to find the deadband, the formula is plus or minus 2 power minus b divided by 1 minus modulus of a. So this modulus of a is nothing but a constant value here, and this b for integer, the initial condition for integer as an initial condition, the b value is equal to 1, right? So here deadband is equal to plus or minus 2 power minus 1 divided by 1 minus your a value is 0.95, so the value is 10. So here let y of it be the response of the system when the product is quantized by rounding. So always while finding the limit cycle, we'll go for rounding, right? So here your q y of n equal to quantization of 0.95 y of n minus 1 plus x of n. So here with this q of this one is nothing but quantization, product quantization, that too by rounding. So here the first step is y of n minus 1 equal to 13, x of n so equal to 0. So this is the condition they have given, and y of n equal to quantization of 0.95 y of n minus 1 plus x of n. So now we are going to substitute your n value as 0, 1, 2, 3, and we are going to see when the system is going to enter into the limit cycle, right? So here when n equal to 0, y of n equal to y of 0. Replace your n as 0 here. So here y of 0 equal to quantization of 0.95 y of 0 minus 1 plus x of 0. So here 0 minus 1 is going to be minus 1. Y of minus 1 value is 13. X of 0 is going to be 0. So quantization of 0.95 into 13 plus 0. So quantization of 0.95 into 12 is 13 is equal to 12.35. So here we are going to go for rounding. So 12.35 rounded value is going to be 12. So your y of 0 is going to be 12. Quantized value y of 0 is equal to 12. Similarly, we are going to substitute your n value as 1, 2, 3 until we are going to get the value of y of n value as 10, because that is the what we have identified the deadband 10 as deadband here, and we are going to see at which period it is going to enter into the limit cycle. So y of 1 which is equal to, replace your n as 1, so y of 1 equal to, so 0.95 y of 1 minus 1, replace your n value by 1 plus x of 1. So y of 1 minus 1 is going to be 0. So y of 0 value is going to be, here it is going to be 12, and x of n is going to be 0 for n greater than or equal to 0. So the value is going to be 0.95 into 12 is going to be 11.4. The rounded value of this 11.4 is going to be 11. So y of 1 quantized value is going to be 11. So similarly n equal to 2. So y of 2 minus 1 is going to be y of 1. So y of 1 that we have found quantized value is going to be 11. So 0.95 into 11 is going to be 10.45. So the rounded value is going to be 10. So now when n equal to 2, the value is going to be 10. So now we are going to make sure that whether it has entered into the limit cycle or not. So when we will say it is entered into the limit cycle, even if you change your input, the value is going to be same. It should retain in the same value here. So now we can see n equal to 3. So 3 minus 1 is going to be 2. So y of 2 is equal to 10. So 9.5. The rounded value of 9.5 is equal to 10. So now we got the same value as in the consecutive time period. So this means that your system enters into the limit cycle. So the system output becomes constant for n is greater than or equal to 2. So deadband is 10. So this is the characteristics of your limit cycle. So the system enters into the limit cycle. So this is the problem for your practice. So Similar method, you can try this one. They have given your system, the excitation condition here, and here we have to see the initial condition. So if the initial condition is integer, the previous, the whatever the step we just saw here, so you have to use the same step here, right? So determine the dead band. If your initial condition is not an integer number, it's going to be your floating number, then it's going to be a different case here, right? So that we saw in the earlier videos here. Thank you guys. Subscribe my channel for automatic update. Have a nice day.